Here we are in Chapter 4 Review. Graph the solution to the systems of inequality labeled the vertices for numbers 28 through 30. So remember here the rules for sketching those regions. First, draw that border line as a line, treating it as an equal sign even though they're not equal. Then, if it was a greater than less than, do it dashed. If it was an actual equals, then we do want the line solid, and then shade up or down, depending on whether or not the y is greater than or less than. And then of course find that vertex, label the vertices, which means wherever there is a corner. So that means we're solving the system as though it were just an equal sign. So let's go through that. We'll do it with blue and red making purple. So this guy right here, let's do this in blue. Let's solve it for y, and we are going to have y, and we're going to subtract the 2x and then divide by a negative 3, which is going to be greater than 2/3 x minus 2. Let's make sure that's right. Subtract the 2x and divide by a negative 3 and a negative 3. So we get y is greater than 2/3 x minus 2. So we're at negative 2, and it's up 2 over 3. And this is going to be a dashed line. Okay, so there's our dashed line. And now we need to shade on which side. Now, with y by itself, we can trust this. So y is going to be greater than. That means we are looking up from the line, the top side of the line. Now you have to be careful. Notice when we divided by a negative sign, it switched the direction of the inequality. So even though it started out looking like we would be under, that is not correct. We are looking above the line. Okay, let's do the next one. Red. So we subtract 7x and divide by 3, and we get y is less than negative 7/3 x plus 7. Let's double check that that's correct. Subtract 7x, divide by 3, that'd be a negative 7 over 3, and 21 divided by 3 is a 7. So we're up at plus 7, about there, and then we're down 7 over 3. And this will be a dashed line because it is not equal to. Okay, and then which way do we graph? We're going to graph under the line, so looking down from the line. So all this down here. And again, on each of these, we could double check that we are correct in our shading. We could pick a random point and see if it will work. For example, on the blue one, if we picked 0, 0, we could stick it in here or here. 0 minus 0, is that less than 6? Yep, so the blue would indeed shade 0, 0, not the other side. Or if we put it in here, 0 greater than 0 minus 2, same effect. On the red line, if we put in 0, 0, is 0 plus 0 less than 21? Yes, it is. Or is 0 less than 0 plus 7? Yes, it is. So both of them are shaded on the side where 0, 0 is on the side of that line. Good. Now we need to look where they cross. So under the red line, above the blue line would be right here. So that guy right there is the solution. The purple is. Second part of the instructions, label the vertices. So we got to find that point. It looks like 0, 3, 0. Let's check and see if that's right. Let's solve the system of equations. 2x minus 3y equals 6, and 7x plus 3y equals 21. This looks like it's very well set up for elimination. Or we could have used these two, the actual blue, and done substitution, but there are a lot of fractions in there. This looks pretty good. If we add those two lines together, we get 9x equals 27. And divide both sides by 9, we get x equals 3. Yes, excellent. Stick 3 up in for either one of those. We get 2 times 3 minus 3y equals 6. That's 6 minus 3y equals 6. And subtract 6 from both sides, minus 3y equals 0. Divide by negative 3, and y equals 0. So that is indeed the point, 3, 0. Excellent. Number 29. Let's solve for y, and that's just subtracting 8x from both sides. So we have y is greater than or equal to negative 8x minus 2. So we're down here at y-intercept negative 2 and a slope of down 8 over 1. Ooh, that guy is pretty. Oh, yeah, I like that. Notice I have graphed it in a solid line because we are equal to. That's important. All right, let's do the other one in red. Oh, wait, which side are we shading? Yeah, y is greater than negative 8x, so that means we're from here looking up this way. So we'll graph it out that way. So all of these points will work. We could double check with a point out here randomly. I like 0, 0 because it's so nice. 0 plus 0, is that bigger than negative 2? Yes. Or is y bigger than or equal to 0 minus 2? Yes. So that side with 0, 0 would be the side we shade. If you try any of these points, they will not work. All right, let's do the second one. In red, subtract 5x, divide by a negative 2. So we're going to have y is greater than or equal to, because we were divided by a negative number, 5 halves x, and then that would be negative 17 divided by a negative 2. That's plus 17 halves. Double check that. Subtract 5x from both sides. And so we have a negative 5x minus 17. Divide by a negative 2 turns that to a positive 5 half x plus 17 halves. So positive 17 halves would be somewhere up here. That's like 8.5. Yeah, about right there. And then slope up 5 over 2 be about like that. Pretty steep slope upward. And so it goes down like this. All right. Yeah, almost a straight line. And do we shade up or, I graphed it with an equal sign, so that's why it's solid, not a dashed line like these other guys were. And then y is greater than, that means it's looking up or out this direction. Now double check. Notice we did not, on the red one, graph 0, 0. Just double check that that would work. 0 minus 0, is that smaller than negative 17? No. Or is 0 greater than 0 plus 17 halves? No. So yeah, it shades on the opposite side of 0, 0 for that one. So let's do purple. And it looks like that. It's that sliver right up at the top. And we got to find the vertex, which is going to be somewhere in here. Man, don't know what that's going to look like. Let's solve it. 8x plus y equals a negative 2, and 5x minus 2y equals negative 17. So now we got to find the solution to this. I am inclined to do elimination. So let's do that with an orange color. If we times everything here by a negative 2, nope, not a negative 2, a positive 2, then that will make that a positive 2y, and we'll get rid of that. So that will be a 16x plus 2y equals a negative 4. So I just took that and multiplied it and put it right down below. So we have 21x gone equals negative 21. Oh, good. It came out with x as a negative 1. So let's stick that back up here. And we get 8 times a negative 1 plus y equals a negative 2. Remember, it doesn't matter where we stick it. I just picked one of those two lines. And we get negative 8 plus y equals negative 2. Add 8 to both sides, and we get y equals a 6. So x is negative 1, y is 6. Negative 1, 6. I don't know. I don't think the non-straightness of my lines, I was a bit off. But hey, that's in the same area. That's good. All right, let's move on to number 30. Solve for y. Let's color this one blue. So we get y is going to be less than negative 4/7 x plus 2/7. Make sure I did that right. Subtract 4x over and divide by 7. So we subtracted 4x divided by 7, and that 2 was divided by 7. Good. So we got a positive 2/7, just a small little guy here. And then down 4 over 7 looks about like that. 1, 2, 3, 4, 1, 2, 3, 5, 6, 7. Good. And we are going to be a dashed line here. Good. And let me see. Are we going to be above or below? We're below. Y is under the line. So we are headed out this direction, out here. You can double check. 0, 0 should work. 0, 0, is that less than 2? It is. Or is y less than 0 plus 2/7? It is. Good. Now let's take the other equation with a red, and we are going to subtract 2x and then divide by a negative 1, which means that's going to be y is greater than or equal. So subtracting 2x and then dividing by a negative 1, that's going to be a positive 2x and a minus 10. So we're going to be down here at like negative 10 and then up 2 over 1. It's going to look like that, and we have an equal sign, so this is a Oh, missed him. Solid line there. There we go. And are we above or below? We are above. Even though we started out with a less than, we divided by a -1, which flipped the inequality. So we are y is greater than. Now, double check that we're actually on the right side. If you stick in a point, 0, 0, or any other point, but 0, 0 is so easy, it should work based on what we graphed. We say we're above the red line, so 0 minus 0, is that less than 10? Yes. Or 0 bigger than -10? Also correct. All right, good. So let's color in purple, which is above the red line out here and below the blue. So it looks like this guy. Yeah, there we go. And then, excellent. Let's find the vertex for the last part of this one. All right, so we have 4x plus 7y equals 2. And we have 2x minus y equals 10. Looks like elimination is doing pretty good here. If we times the whole bottom by 7, or we could do it by a -2. Do we want to get rid of the x, or do we want to get rid of the y? Let's get rid of the y. Times by a 7. And we're left with 14x minus 7y equals 70. Oh boy. Adding those two together, 4x plus 14x is 18x. 7y negative 7y, that's why we did it, was to get the y's gone, and then 2 plus 70 is 72. Divide by 18, divide by 18, and x equals 4. All right, so x is 4. Good, that gives us half of the vertex. Stick 4 back in here somewhere. Let's try this one. 2 times 4 is 8 minus y equals 10. Subtract 8, we get negative y equals 2. Divide by -1, and y is a -2. So 4, -2. Hey, that's kind of close to where it looks like it would be. 4, -2. Excellent.